Thank you. Yeah, so hopefully this is a talk about how testing will make you happy. Maybe not, I'm not sure. But that's the aim. I had a tiny panic this morning when I realized I left my cable at the user group that I spoke at last night, and my laptop was completely out of battery. So we're going to play Spot the Slides that Trish didn't have a chance to make up properly yesterday. What could possibly go wrong? Right, enough about me. You guys, hands up if you're a developer. Most of you. Hands up if you kind of identify as being more of a tester. Okay, cool. And I don't know, there was probably some overlap between those two people. That's fantastic. So I'm going to tell a story about how, so I work for JetBrains. We make IntelliJ. Who's using IntelliJ or ReSharper? A chunk of you, good. The rest of you should definitely do that. Pick up a leaflet down here and get on it straight away. But this is not a talk about JetBrains or about IntelliJ or about tools. This is a talk about when I worked at MongoDB, which was my last job, how we changed our approach to testing for MongoDB. So this is a use a new technology and all your problems will be fixed talk. No, it's not. Thank goodness it's not one of those. I am going to touch on a technology. I'm going to talk about a technology which helped us, but I'm going to talk more about why this particular technology solved our particular problems around testing. So I really want to talk a little bit more about why we as developers are not always super awesome at writing tests, sort of look into some of the reasons for that, and how you can perhaps attack some of those problems. That's the theory anyway. So let's have a look at why we don't write tests. I'm going to try a bit of audience participation. This might go horribly wrong, so I apologize. Okay, let's... Oh, I knew this was a bad idea. Okay, cool. So this is like a quiz show type thing about... So name me a reason why you don't write tests when you should do. Too hard to set up. Hey, you read that. Other than too hard to set up. All right, fine, let's do that. Oh, what's going on? I knew this wasn't going to work. I put macros in here and everything. I had to write VB script yesterday. It was revolting. All right, format. Let's do the old school way. It's probably because my laptop ran out of battery yesterday. Right, yes, too hard to set up. Well done. Yes. Yes, good one. Well, actually, I'm going to put that on too hard to set up because legacy code is generally not designed to be well tested, so you have to put in place frameworks. Yes?
The tests become not usable anymore because the code changes.
Right, the tests become irrelevant as the code changes. That's a good one, and I don't have that one. Yes? All right, you don't think the tests are very valuable. I've got that somewhere. Don't read it, okay? I'm going to call that effort versus value. Right, this is, yeah, I've totally done this talk loads of times before. You can totally see this works. Yes, somewhere over here, someone had a hand up. Yes. Too difficult to work with dependencies. Okay, I've got one of those too. I'll stop reading, everybody. Too hard to mock, or stub or whatever. Yes.
Too much time.
Yes. Actually, I thought that would be the number one thing that people said. I know you're all reading this, but that's fine. You'll get the answers right. We'll get through it quicker. So yeah, number one reason normally is, I don't have time to write tests. And then, of course, it comes and bites you in the arse later on when you don't have time to refactor either, and your code is a big fat mess.
Yeah, or if you're in a brownfield system, it's hard to set up mocks and things.
Right. I'm going to classify that as too hard to set up and too hard to mock. But yeah, you're right. I mean, legacy code or code which is kind of, evolving is difficult. Testers are supposed to write tests. Okay, that's a good point. I don't have that one. Yeah. Right. So the person who writes the code shouldn't be writing the tests because you know what the code looks like, so you're going to write the tests so that they pass your code. Yeah, totally. I don't have that. I guess a lot of people who answered this were more TDD type people, so it's less of a problem. Still a problem. Yep.
I worked for a company that wouldn't allow me to.
How outrageous! Quit immediately. Right, so working for a company that doesn't let you write tests. It's not unusual. Worked, yeah. It's not unusual. I had a number of people say that actually on Twitter, not allowed to write tests. I didn't put that down because I thought that was outrageous and shocking. Right, okay, well, let's move on before this gets too involved. Right, format, oh God. And I'm using Excel and I'm using Windows and it's all sort of fairly new to me. Lots of people saying single-use code, so scripts, prototyping one-off, and then more or less all of those same people afterwards saying, I really wish I'd written tests for that stuff because it ended up in production at some point. The code is simple. It might start off that way, but it almost definitely doesn't end up that way. And the code might be simple for you, but the test isn't necessarily for you. The test might be for future maintainers. UI code, yeah, it's tough. It's certainly tough to unit test UI code. Not enough time, effort versus value. I'm the only maintainer. So I don't need to write tests because I understand my code. And that might be true for you lot, but I have the memory of a goldfish. I have no idea what my code does 5 seconds later. I had 2 more things which I really wanted to put on here. One was, I don't write tests when I want to do things the hard way, i.e. I'm masochistic. And then the other one was, I don't write tests when I want to inflict pain on my coworkers. Nice, okay. And in actual fact, let me just quickly turn off my Wi-Fi before someone tweets me something inappropriate. Right. Not that that's ever happened to me before. And now I'm stuck because I'm in the wrong mode. Oh, I'm so sorry about this. I am a professional presenter. This is what I do all the time. Escape that. Yeah. Right. So we don't write tests because we don't have enough time, because it's hard, because if we're writing tests second, things are difficult. So it's hard to write tests. And the funny thing about testing being hard is that as developers, we don't really have a problem with hard problems. We actually like hard problems. If someone says, if a business comes to us and says, I have this problem that's really difficult to do, we go, yes, bring it on. And then if someone says, would you want to test this legacy system? You're like, not really, it's a bit hard. So we have this kind of weird mindset towards testing. So what are tests for? Automated tests or even manual tests. What is it that we think we're doing when we're testing stuff? Well, that's obvious, right? We're checking that the code works. That's what testing is for. But I think that's one of the things that leads us into this trap of not writing tests. Because we know the code works. We wrote the code. It's totally fine. Or we're about to write the code if we're doing test-driven. So writing code that checks our code works seems a little bit of a waste of time. It often feels like a duplication of effort because we've written the code. So writing a test that proves the code, well, we've already done that. It works. Of course, it's perfect. But there's a number of things that tests are actually good for other than checking that the code works. So, for example, can you read that? Oh, that's not too bad. Obviously, there's the quality thing. But it's not just a case of making sure that your tests work right now. It's obviously regression testing and running them over time, making sure that your code continues to work in the future. Maintainability. So it's not just about checking that once I've written my code, it works. It's about giving me the safety to do things like refactoring. So so I can refactor in safety and know that everything still works. Design. If you're doing testing up front, test-driven development, test-driven design, writing your tests first can influence the design of your code, and it should influence the design of your code. It allows you to inject dependencies. It allows you to make it easier to test. A lot of these brownfield and legacy codes are difficult to test because they haven't been written test first. So by writing tests, whether it's first or second, you can influence the design of your software. Reliability. It's not uncommon for tests, maybe not so much unit tests, but integration tests or acceptance tests, to occasionally fail, and not in a predictable way. So sometimes that's a sign of a flaky test. but sometimes it's a sign of something deeper in your system in terms of reliability. It can point to things like race conditions. It can point to, I don't know, dependencies on external things which might not be super reliable. So testing also gives you an idea of the reliability of your testing. And you don't always know whether it's the reliability of your test or the reliability of your system. But if you have this as a metric to bear in mind and take this seriously, you can dive in and figure out whether your system is the problem or if your tests are. We had a tool at LMAX. So I used to work at LMAX, like Martin Thompson as well, and we used to do a lot of this testing stuff quite right. And we had these big acceptance tests which test everything end to end. And some of these tests would be failing because the functionality is broken or perhaps not implemented yet. And some of these tests would just intermittently fail. So my job at the beginning, not my job, I signed this to myself because I'm enormously OCD and seeing red on the board drove me crazy. What I used to do in the mornings is I would check to see which tests were really failing and which tests were just intermittently failing. So someone else decided this was a waste of my time, took away half of my job and automated this and created a tool called AutoTrish. Which is nice. And they still use that now, and I left them like 3 years ago. And that will give you an indication of the reliability of the system. And over time, because they have visibility over these intermittent tests, they've been able to get reliability from their tests and from the system. It has actually allowed them to see where there are issues that they can fix, not just the correctness of a couple of lines of code, the reliability of the overall system. Documentation. Now for me, so I'm more of a visual person. So although I can read code and kind of understand it, I mean, I've been doing it for 15 years, I ought to be able to understand it, I much prefer tests to document what things are supposed to be doing. I can read a method and figure out what it thinks it's doing. What I like about tests is they should document what you think the system should do, the behavior it should have. So if I insert this sort of document into MongoDB, it should fail with these conditions, or it should not fail under these circumstances. So you can document that better, I think, with tests than with comments or with the code, even with nicely written code. And finally, this is a kind of weird one. In MongoDB, what I was working on is a Java library which your JVM application can use to talk to MongoDB. And so we don't have a UI. Our user interface, if you like, is our API. So we actually found that by writing tests which exercise the API, we get an idea of how usable that API is for Java developers. So it's a different kind of usability to clicking this button here and putting these images in this part of the screen. But it does allow you to get an idea for the usability of your code, the usability of your system, from a developer point of view. And maybe even if you're doing UI testing as well, but that's not an area I've looked at for a while. So, how can we change attitudes? How can we shift from this testing is to make sure it's correct attitude, and my code's perfect, to testing has is a first-class citizen. It belongs as a very, very important part of what we do as developers and what we do as a team and what our system should do. So testing is also about documentation and usability and all these other things. So how can I force my co-workers to see things the same way I do and really understand that testing is a first-class citizen? Well, actually it doesn't really matter whether other developers have in their mind exactly the same thing that I have in my mind. What matters to me is that they behave the way I want them to behave. I want my co-workers to be writing tests. I want them to be writing tests which are understandable, they're good documentation tests. They fulfill all those criteria we had on that, what are tests good at. So I don't necessarily have to change people's minds so they believe things like as religiously as I do or whatever. I just have to make it easy for them to behave in a way that we get value out of our tests. I think I had too much coffee this morning. I'm talking far too fast. Right, so how can we change behavior? And this is a really unstable stage, by the way, so I'm going to fall off and kill myself in a minute. How can we change behavior? So for us, it was useful to have a champion. That was kind of me, being the OCD test type person. I'm not going to walk around because it's too creaky. So yes, having a champion who can be the person who really cares about the quality of the tests is a good way to drive overall quality for the whole team. So for example, one of my first jobs, if you like, that I kind of assigned myself was what I didn't like when I first got to the team is that on Jenkins, the build would quite often fail. And we didn't really know whether it was because we had an overnight build of the server, which perhaps didn't, perhaps some contracts had changed, some behavior had changed, or whether the tests were flaky, or whether the code was bad. So because we didn't know why things were failing, we often ignored them. So red builds were like, oh yeah, it's red again. So I do a lot of nagging, I think. I don't like that word. Nagging is a very female word. I do a lot of steering people in the direction I want them to go. So I would kind of get on to chat or get on to email and say, look, the build is red again. It looks like this person's commit broke it. Can you get on it and fix it? One of the things I didn't do is I did not sit there and fix everyone's broken builds, because that's not the job of the champion. The job of the champion is to delegate to other people and say, look, you should care about these things. So making sure that we took red builds seriously, making sure that we had things like static analysis tools. Again, I guess that's maybe because I'm a bit OCD, but I wanted people to take consistency and style very seriously. So we had check style and find bugs, and we fixed those errors between us. We dished them out between the whole team. And then we made sure that we had 0 check style and find bugs errors going forward. That would fail the build if there were any errors. What else? Oh yeah, and we did code review. So I quite like pair programming, which is what we did at LMAX, but we were a distributed team. So we kind of had to do the code review thing more because of the time zone difference than the distance, because you can do it asynchronously. So in code reviews, people learned very quickly that the first question I was going to ask when I was reviewing someone else's code is, where are your tests? And then people would say, I have one test. I'm like, yes, but you wrote 200 lines of code and you have one test. You should probably have at least 200 lines of code worth of tests. And I don't just want happy path tests. Happy path tests are very easy to write when you wrote the code first, and then you write the test to check the code does what you thought it was supposed to do. But what you should be thinking is, okay, well, what if someone calls this with something weird? What happens if someone pokes a null in here? What happens if the server returns with an error? Or, of course, the server could easily return with nothing because the network connection could drop. So for every happy path test, I'm expecting, I don't know, 3, 4, half a dozen unhappy path tests. So I was pushing on that stuff. So as I kept pushing people in the direction I wanted them to go in, doing these things becomes a habit. So keeping Jenkins green is something that we all do. Making sure that check style passes is something that we all do. Making sure that we have tests in code review is something that we just get into the habit of doing this stuff. So I don't have to nag anymore, and the whole team just kind of does it because it becomes routine, it becomes habit. Now this can only get you so far, because especially if you're trying to change behavior and you haven't necessarily got everyone's buy-in into thinking the same way as you can't necessarily get everyone to do everything the way that you want them to, especially if I found it difficult to articulate some of the things I wanted from people and why I wanted tests to be a particular way. I don't want them to just kind of write tests a particular way by like habit and by rote and not thinking about it. I want them to understand this stuff. And if I haven't articulated that very well, then they're not going to buy into it. So we still had a bunch of other problems. So I'm not sure if you can read that. This is where we spot the slides that I wrote on a piece of paper this morning. We had a number of other problems. So we have a complicated matrix of capabilities. What this means is that we have our jar file can be used by anyone. It's a downloadable library. So it needs to be tested against Java 6, Java 7, Java 8. We need to be able to run against all the most recent versions of the server. So server versions 2.2, 2.4, 2.6, 3.0. So we already have a complicated matrix of stuff. On top of that, we have some tests that run against replica sets, some tests that run against single servers, some tests that run in the sharded environment. So things get kind of complicated. We still have this tendency to only write happy path type tests. It's just not in our nature to try and break the system. We're developers, we kind of want to make sure it does what we said it was going to do. I think this is compounded by the fact that our team didn't have any QA or tester type people. We only have developers. And I think QA people are really brilliant at helping guide you into this mindset of how can I break it? What could go wrong? And developers are not as good at that. We didn't have any unit tests, which I thought that was a smell, because I feel like with unit tests, you can run them much, much quicker, and you can get fast feedback, and not everything should require you to have the database up and running. Consequently, because we had a lot of functional integration tests, lots of tests had a lot of setup to get everything in the right state before we could poke it with whatever values we wanted. We were, again, a sign of the same problem, testing too many things. So once we've done all that complicated setup, we're like, well, we won't just do one assertion, because you just spent ages setting up the server in the state we want. So we're going to assert this, try this, do the other. And that's kind of, certainly when you're using JUnit, that's not a very good pattern to follow. We had horrible test names. Test basic 2 springs to mind. Test doesn't fail. Oh, good. That's nice. Difficult to see what's under test. So because we have this long setup, because we have complicated functional tests, you don't really know when you're looking at sort of 30 lines of test code, which bit is the bit I'm really testing and which bit is the stuff that just gets the server into the state I need it into. Consequently, the tests are difficult to read. And we have many similar tests. So, and this is kind of good practice in JUnit, where you have one test which tests like inputs 1, 2, 3, another test which tests input ABC, another test which tests input null, and they should be separate tests, because if something goes wrong, they should fail separately. But this was kind of cluttering up a lot of our test code base. So in order to fix a lot of these problems and address these problems, we need to make it as easy as possible for developers to do the right thing. So I investigated a bunch of solutions. I'm not really going to go into the details of this, because the slides are available online and you can look up all of these things. But the point of this slide really is to show that I'd heard about Spock as a possible solution for testing problems, but it wasn't the first one I jumped on. It's not like I went, oh, Spock, that's in Groovy, that sounds amazing. I don't know Groovy, I'd love to add it to my CV. That did not go through my head. I went through a bunch of these other things. But my ex-colleagues at LMAX have been playing with Spock, so I learned a little bit about Spock and decided I'd have a look at what Spock could do for us to fix some of our remaining problems. Now, normally, I wouldn't necessarily look for a technical solution to a kind of process problem, because then you probably end up with 2 different problems, especially because Spock is a library written in Groovy, and you have to write your tests in Groovy. We're a Java driver. We're a bunch of Java developers. We are going to be used by Java people. It doesn't seem to make a lot of sense to bring on a different JVM language to test our code. So I wanted to be really careful to make sure that Spock actually fixed the problems that we were having before we made the leap to a brand new JVM language just for testing. So let's have a quick look at a simple Spock test. Is anyone here using Spock? Oh, quite a lot of you. That's good. So you guys can snooze for the next 10 minutes. That's fine. And who's using Groovy generally or has awareness of Groovy? A few of you. And who, well, are other people Java people, or you don't really care about the technology? Java people? Oh, a chunk of you. Okay, cool. And the rest of you don't care about technology? You can snooze as well, that's fine. So I'm going to go through a little bit of what Spock looks like, because what I want to do is say the sort of process I went through in evaluating this to fix our particular problems around testing. So I kind of want to point at this, but I'm a bit short. There's a number of things that occur to me when I look at this. This is a very simple Spock test, but it's a genuine one that lives in the MongoDB Java driver code base. Firstly, the test method is a string. The method name is a string. And actually for tests, that's really nice, because you don't have to, people stop freaking out about writing long method names. They can actually write something long and descriptive in there with stuff other than just lowercase. You can use camel case and whatever you want to. And so it kind of frees you from this test basic 2 mindset. The thing which really drew me to Spock, though, is instead of having an annotation like test to say this is a test method, you use a series of labels, in this case, given, when, and then. There are other ones, but given when and then are my favorite ones. So this gets you into the BDD style testing mindset. This forces you to split your test up into, this is the setup, this is the stuff that's actually under test, and these are my assertions. And so once you've split it up into those three sections, you can start to see any smells in your test. So you can see, oh, I've got like 25 lines of setup for one line of test. The least I could do is extract that out into something usable, or perhaps my test is doing far too many things. Or, as quite often happened to us, especially when we were translating old tests into new tests, when we couldn't figure out what goes under the when bit, then we're definitely not testing the right things. Because you should be thinking, what is the thing I'm really trying to test here? When what happens, should what happen? So yes, and then under your assertions, obviously you can tell whether you've got too many assertions, and you can figure out what's a real assertion. And sometimes, you know, when you scatter assertions in the setup just to make sure the setup went right, you could kind of tell that you're doing that if you follow this pattern. What else? So I'm a Java person, and lots of people always complain about Java boilerplate and how painful it is. And I was like, well, whatever, I don't really care, because like I'm a Java person, I just ignore all the boilerplate. Until I came to looking at the way maps are done in Groovy. And I was like, oh, like key value pairs, that's nice. And I have to do an append with like 2 parameters. It's just much nicer when it's laid out like a key value pair. MongoDB is a document store, and documents look like JSON. So a lot of what we did was creating these map objects to be turned into JSON to go into MongoDB. And it's ugly, it's painful. But with the Groovy testing, we found that the map syntax was much more descriptive and was clearer for us, even as Java people, it was clearer for us which documents we were creating and what we were doing with them. What else? And the assertions, you can say equals instead of assert equals or assert that or assert false. So again, it's kind of a little bit more readable. So even if you've been doing JUnit for, I don't know, 7, 8 years like I have been, I actually found this a little bit easier to read than JUnit tests. So how do these Spock tests fix the particular problems that we had? Well, we'll go back to the example I just showed. One of the problems we had is that they were hard to read. And all of the members of the team generally found that the Spock tests were easier to read for a number of reasons. One, the given, when, and then really puts it into your brain, like what's happening in the test, what's really under test, what's set up, what am I really trying to do? And the string method names also make it kind of easier to tell what's supposed to be happening in the test. So similarly, we had these horrible test names. So again, the string method names that made us have much better test names. This is actually one of the shorter ones. I didn't put the really descriptive ones on there because it wouldn't have fitted on the slide. So the problem we had was that it's difficult to tell which thing is really under test. Spock has an annotation called subject, which is not mandatory, but you can put it in there as a sort of documentation annotation. So you can say, look, in this case, we're testing MapReduce. So the MapReduce output class is the thing that's under test, and the thing that happens after the when label, that is the thing we're testing in this specific test. So it became a bit clearer what we were really trying to achieve. And again, if we were doing translation from our old tests into new Spock tests, and we couldn't figure out what the subject was and what the when was, that test had fairly limited value. Lots of setup. So again, the same test here. If you do have lots, this is again a much shorter example than some of the examples we had. If you do have a lot of setup, it becomes very obvious that you've got lots of setup because it's all in given. And so you might want to refactor that stuff out. Or worst case, you keep everything in given, but you can just ignore that because you know that's setup and skip straight to the what am I testing, what are the assertions. We didn't have any unit tests because mocking and stubbing is kind of tricky. And we didn't want a lot of dependencies. The production code has 0 dependencies. We didn't want to have loads of dependencies in our test code on things like Mockito or JMock or whatever. So we found mocking very challenging when you don't have a mocking library to help you out. With Spock, you get mocking for free, and it's kind of super easy. So you just say, at the top there, you just say, I'm going to mock this thing, and it sort of does it for you magically. And then at the bottom, these are the assertions you have on your mock. So this is checking that if I encode an array, those particular methods on the writer get called in order. I was learning Spanish, by the way, which is why it says uno, dos, tres. So here we expect one of these, one of these, one of these. So unlike a lot of other mocking frameworks which I'd used, I found this easy, painless, and readable, so I can see what I'm expecting in the assertions. And the assertions are at the bottom of the method as well, unlike something like JMock, where you have to set up at the top what you are expecting the mock and stub to do. So it's sort of backwards. In Spock, all the assertions are at the bottom where you expect them to be. We were terrible at writing unhappy path code tests. Spock makes this a little bit easier as well, because we could do, I'm going to go over here, I'm going to change sides. You can do tests which make sure the specific exception is thrown. Oh, that's not a fantastic example, actually. Not only can you do a test to make sure that a specific example is thrown, because you can do that in JUnit too, but you can get that exception and you can query things like the root cause of the exception or the message or whatever. So you can do a lot more proper assertions on your failure cases than you can in JUnit. And one of the other things I really liked is it's explicit about when exceptions aren't thrown. So we used to have a bunch of tests which had no assertions. It did a bunch of stuff and then didn't have any assertions. And I couldn't work out what it was testing. And of course what it's testing is you don't get an exception. And I'm like, well, that's kind of weird. Let's be explicit about that. So here I'm checking that if I do this with an invalid URI, I don't get an exception. It's totally valid. So if you have a bunch of tests which look really similar, sort of copy-paste testing with lots of slightly different inputs and outputs, Spock has data-driven testing. So I can put in like the criteria, something to sort by, and then the expected ID. For example, I can put in whatever I want. And that allows me to run the same sort of test with different inputs and outputs. And that's really powerful, especially for something like a database driver, where what we do is take input, do something to it, and put out output. And we quite often want to put in different types of input to the same method. Similarly, when we had the other problem, which is one test which tests everything, we could split that again into one of these data-driven tests. And one of the really nice things about the data-driven tests is it's not super clear, but if one of those lines is kind of, well, I'm red-green colorblind, so this is not very obvious, but there's like an orange failure halfway down there. If one of the inputs and outputs fails, then you just get just that one failure coming up, and you can see all the others are run, and they're all green. So you know that the failure is just on that particular input-output combination, and it's not, say, something wrong with the encoding overall. One of the other things is that Groovy has really nice assertions. It's really helpful at telling you what's actually wrong with your code, which bit's failing, whether, like here, again, you can't see it very well, I don't think, but you can see the value of collection, the value of find one, the value of criteria. So you can see exactly what caused the problem. We had this complicated matrix of versions, if you like. And you can do, this is not, I don't think this is just a Spock thing, we just found it easier in Spock. You can do ignore if. So for example, when we were doing testing on legacy things, we're not going to run this on the 3.0 server because it doesn't support this. We're not going to run this particular thing on Java 1.6 because it doesn't work. We're not going to run this if it's a replica set thing because, I don't know, I assume it doesn't work with replica sets. But again, that kind of documents the expectations of those tests. And previously, we kind of had ifs inside our test methods, and they would just kind of not run, but they wouldn't pass or fail. Whereas these are literally, they're ignored tests under the circumstances where they're not supposed to run. In Spock 1.0, which I haven't used yet, there's also a requires annotation. So kind of the other way around. You can say requires Java 8 if, for example, we had some Java 8 specific stuff. Right, so that's kind of everyone who went to sleep can wake up now. So we kind of we ran with this for quite a while. I did a week-long spike first to make sure that my questions were answered. But we ran with it for a bit. And obviously what we want to do is keep checking in to make sure that Spock is giving us what we want. Are our tests giving us more value than they were before? Is it worth it having this different language to test the library? Maybe we could have just learned to write better tests. So I think Jay's talk after this is going to do a lot more about how you write good tests. And I kind of decided to go for a framework which kind of forces you to write in a BDD style given when and then, rather than trying to coach the team on how to write better tests in JUnit, which is entirely possible, but it requires a bit more discipline. So what I found is, so I wanted Spock originally for unit tests because it's got great mocking, and we didn't have any unit tests, and I didn't really want to complicate things by saying we're going to have integration tests in Spock and Java. We're going to have like old style Java tests, new and not so bad Java tests, new Spock tests, and then Spock JUnit tests, because I just thought that was going to be crazy. But what happened was everyone was enjoying Spock so much and found it so readable and so easy to write tests. They started writing functional tests in them, and they started using Spock like pretty much wherever they could because it was easier, faster, and more descriptive to write tests this way. So the fact that the rest of the team, which, don't get me wrong, they did write tests, but they were not super excited about writing tests, were kind of rolling Spock out across the whole library, means that, in my mind, it was a success because people were enjoying writing tests. I'm going to say enjoying, yeah, sure they were enjoying it. But they were preferring to write tests in this particular way rather than in JUnit. What else? Oh yeah, and it proved itself time and again because as we were writing more tests, because it was easier, it's a little bit more fun. No one on the team was actually one of these, oh, we need to learn a new language type thing. So we weren't like super excited about writing Groovy tests just for the sake of learning Groovy. But it was kind of fun learning how to use Groovy as well as part of the testing. So we wrote more tests than we would have written before. Obviously, we started catching more failures. So more failures in our code. We were often running against a nightly build of the server, so we could feed back to the server team quickly if something like an error message had changed and they hadn't published that these things were changing. So we got much better at finding errors before our users found errors, which is a good thing. But we still had a number of issues. Oh yeah, one of the other interesting things, and I don't know if this was because we started getting better at testing or if it was just an evolution of MongoDB as it got more mature, but we started writing specifications for how things were going to interact with the server, but we also, eventually, just before I left, we started writing kind of compatibility kit type BDD style descriptions of, they weren't actually tests, but descriptions of tests to run to make sure a driver was meeting new specifications from the server. So we got this idea of tests as documentation starting to come through the whole company, not just the Java team, but all of the driver team and the server team as well. So that was fantastic, just starting to think of tests as being a much better way of describing the behavior than documentation or committee meetings or whatever. But we still had a bunch of issues. Did we? Yes. Groovy's performance is different to Java's performance. It's a little bit slower to run individual tests. We found that some of our performance-sensitive tests didn't always run in Groovy. And didn't always succeed in Groovy. They timed out earlier than they did in Java. And I'm not sure if we should have got better at writing better Groovy tests, but we ended up writing those tests in Java, the performance-sensitive ones, we wrote them in Java, because Java performance is more predictable. It's not necessarily, well, it is better, but it's not that, it's that it's more predictable. So we kept our performance-sensitive tests in Java. And it was easier for us to keep them in Java than to try and figure out what to do in Groovy to make things better. Dynamic languages, dynamic typing. I'm a Java person. I found it a bit challenging, especially when you kind of mistype a method name or you don't know what type something is because you've defined it as I don't care what type this is, and you only get the error when you run the test rather than when the IDE says, oh, you did something stupid, dumbass. So that was kind of, it's a bit frustrating. The feedback cycle on Groovy is a little bit slower. So I quite like my type safety. having said that, the dynamic language is kind of nice for testing quite a lot of the time, because especially for things like mocks, you often don't really care what type it is. You don't really care what gets called as arguments. You just want it to just function until you tell it to behave differently. And Groovy is very, very good for that. So, to get back to the sort of 3 questions that were in my abstract, how can we, as developers, write tests? Not how can we write more tests? How can we get excited about writing tests? Or how can we encourage our team to write tests? Personally, I am a big fan of pair programming. I haven't done it since I left LMAX. I'm sad about that. Pairing keeps you really honest, because even when you would normally not write a test, when your partner doesn't write a test, then you're like, I think you should write a test for this. And then they say, you should write the test for it because we're pairing. You're like, okay, I'll do that. So pairing is really good at kind of keeping you honest about writing tests. But failing that, you should be doing some sort of code reviews or code demonstrations, or presumably you should be sharing with the rest of your team what you have achieved code-wise. And at that point, it's a good time to ask the question, where are your tests? What do they do? And I found that with code reviews, I find it difficult to read code and grok it straight away. But if there's tests there, I can figure out what the developer thought they were trying to do with this code. And then I can have a look through the code. So it was a lot easier for me to sort of say, where are your tests and where are the failure cases for these tests? Make it as simple as possible to write tests. So in our case, we found Spock and Groovy made it a lot easier for us to write tests. So for example, we create a lot of maps, and Groovy map syntax makes that much easier. The given, when, and then syntax forces us to think about what it is we're really testing, rather than just kind of throwing together some stuff and making sure it doesn't error. So yeah, that just made it a lot simpler for us to write tests. We found it was, me personally maybe, I'm not sure about the others, I found it more fun to write tests in Groovy and Spock. It was just kind of, it's kind of prettier. And I like Java, don't get me wrong, and I'm not jumping ship to Groovy, but I liked writing the tests in Spock. I thought it was, it's just kind of fun to write them in that way. Yes, and if you understand why you're writing the tests, that's also a better motivator. So this kind of, we write tests to check that your code does what you thought it does, is not a great motivator, because we think our code's fine. We wrote it, we probably manually tested it, and it's all right. So there's very little motivation to write a test to check that. But when you think about the fact the purpose of the test is something like documentation, reliability, maintainability, so that I can go back and refactor this stuff later when I want to, then you're a bit more motivated to write the tests. How can we write readable tests? The astute amongst you might notice I swapped B and C from the abstract, but the rest of you don't care, so that's fine. My OCD is going crazy. I was like, I want to swap these around, but I said it was going to be different in the abstract. So writing readable tests. For us, we found that Spock and Groovy made our tests more readable, because it takes away a lot of the boilerplate of Java, which I previously hadn't really cared about. But it's not just about, you don't just have to use a new language for this. There's a library called Gwen, which was created by the guys at Shazam, and that allows you to do given, when, and then inside a JUnit test. So that's cool. That can kind of force you to create these more readable tests. You can create your own DSLs. So we had a DSL at LMAX. It was a Java-based DSL, and we used that for our acceptance tests. So our acceptance test would read something like user.login with this username and password, and the DSL would tell you what you can do with various things. Like obviously I can place orders, I can, I don't know, look up my order history, and we did that with a DSL. And that can just make things more readable. And separating out what's under test, what are the expectations, what's set up, all of that just makes things more readable. And there's more than one way of doing this, and I think that I'm hoping that Jay's going to cover a bunch of this in his talk afterwards as well. So readable test is one thing. I can write a readable test that's kind of useless. I can write a readable test for a getter if you want to. I'm not going to go into why testing getters is stupid. But what we really want is meaningful tests, tests that tell people what the behavior of the system is supposed to be, and also fail for the right reasons and pass for the right reasons. And this is kind of the difficult thing, because this is going to require thinking, which is tough. I find the given, when, and then structure is a really good way to make more meaningful tests. I mean, there are other things as well. When we did the data-driven testing, it wasn't just given, when, and then. But this kind of forces you to think about what's actually under test. What am I really trying to achieve? And how much setup do I need to do in order to do this? This is kind of mental. Maybe I should turn this into a unit test so that I can mock or stub various behaviors. So again, a library like Gwen, which is the other given, when, and then thing, or a DSL might also help you write more meaningful tests. Code review is a really, really good place to catch whether the tests mean anything or not, because when someone goes, I don't really understand what you're trying to achieve with this test, then you've probably not written a readable, meaningful test. Yes, so again, and understanding the reasoning, the why we write tests is a good way to motivate us to write meaningful tests. So not just to check that our code works and that it passes, because of course it does, but to allow us to refactor later, to allow us to not be pestered by new members when they join the team, because we can point them to the tests and they can understand the behavior, to document the system. So one of my jobs was to go on Stack Overflow and answer questions about how to use the Java driver. And my ideal was to be able to say to them, here's a test for how to insert into MongoDB, and all the stuff that you want to know is in that test. So taking the burden off me as a support person. In conclusion, you want to make it as easy as possible to write readable, meaningful tests. You want to automate everything. I haven't even mentioned running these tests in CI, because if you're not running unit tests in your continuous integration environment, well, I was going to say you're doing it wrong, but you've got a really quick win right there. Okay, you should be running these tests every single time you check in. And you should be running, if you are going to do branch type development, you should be running them on the branches too. So we had it in Jenkins, and we had things on Travis, so that when people submitted pull requests, Travis said everything's broken, we can just say, no, we're not going to accept your pull request. So similarly, zero tolerance for failures. When things go wrong, get on that straight away. It's not acceptable to say, oh, I'm working on a new feature, I can't fix the thing I broke in the last feature, because you haven't finished the last feature yet until everything goes green. So drop everything and work on those failures, because you're blocking everyone else. No one should be committing to Jenkins if it's red, because then you don't know if you're just compounding the problem with more errors later on. It helps to have a champion. It doesn't have to be a tester or a BA, or it can just be a developer who's as OCD as me. Or it can just be someone who thinks that we could be doing better. And it doesn't have to be a senior person. I'm not team lead on this. I'm just another developer who just wants things to be better. So have a champion, and preferably, obviously, give them permission to nag people and tell them that this is not acceptable and we should be doing things this way. One of the things I had to learn as the OCD champion was there are some things you are not going to get through. There's some things that the team is not going to buy. And that's okay, just let it go. I'm going to be singing that all day now. Just let it go. I wanted Spock to be just for unit tests, and the team used them for functional integration tests. That's fine, that's good, they're writing tests. So let go of your ideal of Spock is for unit tests. I really wanted us to write acceptance tests, end-to-end tests that exercise the API and describe to our users the behavior of the system. And we never really got that far, because I never could articulate exactly what I wanted from those tests. So I just had to let that go. Pairing and code reviews are kind of vital. Don't just let any old person just check in any old code and say, yeah, it works because I tested it manually. You need that kind of sanity check to make sure that you are, keep people honest with writing tests and writing unhappy and happy path tests. And, and think about the purposes of testing. So I've named some of the things that I find useful about testing: reliability, quality, maintainability. And those are just the ones that I thought of on the plane on the way over. There's probably like 35,000 different reasons to test. And for your team, it might be different to what they are for my team. But it just takes 5 minutes to sit down and think, what value can we get out of tests other than the code does what it's supposed to do? So I have some resources, not for this test, but if you are not for this talk, but if you are interested in Spock and Groovy and Java for testing, I've got another talk about that, but also links to some more information about Spock, some blog posts and stuff like that. So yes, if that interests you, that's all there. The slides will be available online, so if you don't get a chance to photo that, then tough. Yes, so we have no time for questions, sorry. But I am going across the road, across the thing over there to the left. There's a what's it called, the Power Lounge, and I'm going to be there for a meet and greet with Pearson. So you can come over and chat to me, ask me questions. I'm going to be on the JetBrains booth, which is just out there for the rest of the day. So come and grab me if you have any questions whatsoever. Thank you very much.